Part of your drawing set for the contractor will be a series of elevations, which are simply a view as if you're standing at one side of the building, looking straight at that side of the building, and that's the elevation view. Oops, sorry. A lot of people get confused about, okay, how do I name the elevation view? And it's simple if you just remember this. Whatever side the building is, that's the name of the elevation. So if you're on the south side of the building, that's the south elevation. And don't worry about who's looking what direction. It's the south side of the building, so that's the south elevation. If you're on the east side of the building, that's the east elevation, and so forth. These elevations describe for the contractor what the construction is going to look like, and they provide some details about materials and elevations, heights. They don't contain an awful lot of dimensions or details. Those are found on other sheets. But this does give the contractor an idea of what they're going to wind up with. And then there are often all these tags that send them to other sheets to look things up. When you're numbering your sheets, you might recall that 2 is the sheet number for elevations. So if you're doing an elevation of a building in an architectural set, you might number it A201. Then in the layer names, elevation, E-L-E-V, is a major group. So as you're drawing your thing, your layer name in the CAD drawing will be at least A-ELEV. Then if you want to, you can go in and add some minor groups to identify subdivisions of stuff. An elevation includes an elevation mark. How high is it above the ground? And it is represented with this symbol, this circle, divided into fourths. Some drafters don't use the circle. They just make a line and write ELEV and some numbers. We only use the elevation once per drawing. What that means is you would not come over to the other side of the drawing and repeat that number. You'd just put it here. Now, let me say something about the numbers. And you'll see this on LCC building plans sometimes. Sometimes this building might be up at a high elevation somewhere, and you might see an elevation number that just says 40 feet. And you're going, what is going on there? What is going on is that in a big project, like for example the LCC campus, the architect will designate a baseline elevation that's going to be their 0 line. And they'll work that out with the surveyor. So some place on campus there's a benchmark and it says this is 0, and now all the buildings have their heights taken off of that. So that's what's going on there. This is from the National CAD Standard, and it's showing how you could have a key in a small plan view, and around the key you could have these view arrows showing the reader what page to turn to find the elevation, and then which elevation number refers to which particular side of the building, just so there's no chance of getting mixed up. Here's another example from the CAD standard. So showing these view arrows around the plan. Now, as you saw last time when we looked at a plan view of Building 15, you can also put these view arrows inside a room and then refer the reader to where they are going to find interior elevations. For exterior elevations, the outside of the building, here's an example from the CAD standard. And here you can see they are representing the elevation without that circle symbol. You can also see that it's perfectly fine to cut a section through an elevation. Now this thing that we're looking at here could even be a section elevation. It could be a section through a building, and now they are cutting another section looking another direction. It's section number so-and-so, and it's on page number A-3 something. Notice that we include grid markers on our elevation drawings. We want to keep everybody tied down to where these grid lines are. Some elevations are structural. So here is a commercial building that has a structural steel skeleton, you might say, and this is the structural elevation showing where that structural steel goes and a little bit about the foundation. We also have interior elevations. And this is useful for showing what materials to use. There might be some dimensions showing, for example, fixtures in a restroom or cabinets in a kitchen. Here are just a couple of examples. Here is this reference symbol again. We'll come back and look at that next time. So this circle, the number in the top is what elevation thing is it? So this is elevation view number 4. The number in the bottom is what page number is it on. So this one is on page 6 or sheet number 6. That's a bad way to do sheet numbering, isn't it? It should be A-306 or something like that. But never mind that. And so you're seeing here's, let me see, here's an exterior elevation 4-6. And here is a view of what that looks like. There's the entry door, there's the ticket window, and so on and so forth. We can put lots of detail in our interior elevation view. Here are some details for restrooms. This is going to be important when you are following ADA, the Americans with Disabilities Act, which is the law. You have to have various kinds of grab bars and fixtures no more than a certain height above the floor in order to be accessible. Here's another example of an elevation. Notice you can also give some notes about what kinds of materials you're using. And then I think this is the last slide. Elevations, interior elevations, are commonly used with cabinet work. If you work for a cabinet shop and you're either doing bidding or maybe you're going to start making some cabinet drawings, you will come to one of these interior elevation views and you will begin to look at how high are these things, how long are these things, where are the hinges, where are the handles, and so forth. So this interior elevation will be very useful to you as you begin doing that drawing.